Yeah, and so for those of you who are waiting, thanks for joining early. We'll get started here in a second. As you can see here, I absolutely love making this as interactive as possible. So feel free to put your questions in the chat as we go. I would love to make sure that if you have a burning question, we address it when we're talking about it than holding it to the end. But yeah, I think we're 1 minute past, so I'm okay to get started if that works. All right, will do. Thank you all so much for coming to the session today. My name is Denise Gosnell. I am the Chief Data Officer at DataStax, and we are here to talk about seeing the unseen with graph technology. So a few housekeeping items. I have multiple screens here, as I'm sure you all are used to now with these virtual events. So what I have over on this side, when you see me looking in the other direction, is the chat. I'm going to do the best I can, also with the assistance of the team here, to follow your questions as we go. So if you have a question, please ask it. I would love to stop, address it, talk about it, see if I can help explain it better, and kind of get back to the content. Because in my opinion, making sure that we cover what is meaningful to you is why we're here. So please ask questions as you go. So as we go through that, here's what I hope that we're going to be doing today. We are going to talk about who I am and why I am a little bit to talking about graph databases and graph technology. After that, going to cover why now. Why have you all started to see a few different topics and events even here at this conference discussing graph databases and graph data. And the meat of what I hope to talk about is to go into navigating the tech water cooler. I love it when I'm able to take information I learn at a conference or an event and have just enough to go out and teach myself when I go to Google and do different searches, read Medium articles, et cetera, towards data science. So what I would like to make sure we really get into is covering a bunch of different words and terms that you're going to run into when you start to explore graph databases and graph technology, so that you feel informed and empowered to go find your own journey in this emerging technology. So hopefully that sounds good. Yes, feel free to steal whichever quotes you would like to go. You can always reach me on Twitter or LinkedIn, very active on each of those platforms. My Twitter handle is here on the lower left. And for those of you who are out there and have already been a part of this community that I've been building, thank you so much. I've attempted to release a book during a global pandemic, which is a whole new experience in its own. But I am absolutely humbled and honored to say that the book that I wrote with Dr. Matthias Broschela has been #1 on Amazon for the new release in artificial intelligence. We have a few free versions hosted by DataStax. If you want access to some of the free chapters, you can find that with DataStax. But thank you all so much for your support in my book so far. So a lot of the content we're going to be talking about at the end, you do find in the book. So if you do find this valuable, maybe that resource will be a good one for you afterwards. Oh, and thank you for the congratulations. I appreciate it. Personally, what I find to be very relevant to understand at the 30,000-foot view is, why are we talking about graph databases and graph data now? And the perspective I have on that is that data has 3 main properties. All data occurs at a certain time, and that data also occurs at a certain location. The last piece of information that as humans we're really trying to understand is the relationship or the context about that data. Those 3 properties describe almost every single piece of data we're working with. And it's that last one, the relation or the context about data, that is incredibly hard to model in a database or in your code, that graph databases make so much easier to use. And so from my perspective, that's why we're talking about graph databases and graph technology now. The first thing I do hope you all really walk away from this is the fact that graph databases and graph data mirror how we think. They give us a way to represent data exactly how we're processing in our minds, and it gives us technology to use it to make more interesting decisions with your applications. Now, for some of the teams that I have worked with thus far around the world, believe it or not, graph databases are enabling their productivity. Absolutely, with any new technology, there's a really large and steep learning curve when you're picking it up. But here's an example of one of the developers that I was working with told me. They were looking at an application, they had an HBase, and they had one query that was trying to bring together all of the customer data across these different tables in HBase. And that query was about 150 lines long to maintain for their team. When they switched over to using graph databases, that query, that one query, reduced from being 150 lines to 20 lines. When you're thinking about engineering maintenance of code, reducing 150 lines to 20 is a massive improvement. So that's just one way that I'm seeing engineering teams and developers be more productive when they're using and implementing graph databases and graph technology. For this audience and in the machine learning and data science community, one of my most favorite things about graph databases and graph data is that it's giving us a new set of features to bring into our ML pipelines. So much of what we've been focusing on thinks about data as a tabular shape, rows and columns. When you have your rows and columns, but then you bring in the relationships between each of those points to other data points, it opens up this whole new dimension of features that we've been missing this whole time, but are able to make really fascinating decisions and improve different correlations that you have in your models. And that's another reason why I'm seeing this, particularly the data science and the machine learning community really start to bring graph databases and graph data into their processes. And thank you so much for sharing my book links in the chat. So for those of you who might have joined in late, I'm very interactive in these sessions, so I'm doing the best I can to both follow my slides and monitor chat over here. So I'm switching between these two views. So if you do have a question, please let me know. But here's really the bulk of what I want to get into in this session today. It's this theme of navigating the tech water cooler. Because if you're like me at a conference, you tend to talk because you think it's cool. And what you want are those key launch points to go from this event to go find useful information out there to help start your own journey in the space. So if you find graph databases, graph data, graph technology interesting, what I'm going to do in the next 20 minutes or so is to go through a tour of the main terms that you might find interesting across the main 3 segments of graph technology. So when you're working with graph technology, you're probably going to start in one of these 3 spots, or you're probably going to flow through them in this order. You're going to likely start with wanting to understand graph visualization, because that's really where you see the value and you can really understand graph data and why it's awesome. After that, you're probably going to want to dive into graph analysis. This is a data science event, and I am a trained data scientist as well. So we're going to talk about some of the most common approaches that teams go through when they are working in graph analysis. And at the end, we are going to dive into specifically how I've been helping companies around the world deploy graph databases to use it in production applications that you likely touch every day. In the first 2 sections here, we're going to talk a lot about a healthcare example. I find that the visualizations that a team I worked with created are really illustrative for the topics in Viz and then the topics in analysis. So we're going to have a healthcare theme for the next 10 minutes or so. When we dive into graph databases, I'm going to start the kind of having examples get peppered in many different avenues. So we're going to kind of switch away from that and then have kind of rapid fire examples happening. So hopefully that's helpful. And to honor the, hey, ask me a question and I'll answer it. Before we dive into the navigating water cooler, I see a fantastic question. It's about, do you see graph technology as a replacement for relational databases and processes or another tool to use in parallel? Absolutely the latter. It's another tool to use in parallel. You need to use graph databases because the shape of the data that you need to study is more important and better fit to use graph database technology. So here's the specific, for instance, I recommend you think about as a data scientist. When you are thinking about the data you're working with, what is more important? The actual entity and the properties about it, or the relationships it has to other pieces of data in your data set? So you can think about customers and wanting to understand, say, the distributions of their age. That's something that relational technology is well suited for, and we'll be able to answer those kind of questions very fast. On the other hand, if you are working with customer data and you want to understand the different touch points that customer has across your business, the products they've purchased, the stores they've visited, maybe the addresses that they have put on file, those relationships that exist between that customer and other vital points of data, if that's most important to you, that is when graph databases or graph technology is going to start to really shine for the problem that you're working on. So thanks for the question, and hopefully that was helpful. What we are going to start with though here is we're going to start talking about the main terms that you're going to run into if you begin to go explore the graph visualization community. Just six quick terms, and the way that these sections are going to work is we're going to start with a term, and my goal is that you have a visualization or a word to associate with in your mind so that you can begin to understand and pick up on all the terminology that that you would have in the graph visualization space to get started with. The first one is vertices or nodes. Graph tech is loaded with a ton of terms. And so the first one to think about is that a vertex or a node is just a circle, or it's going to be a dot that represents the single most entity. What you're looking at here is the beginning of the healthcare example we're going to use for a little bit. Every vertex on this visualization is a doctor in the United States. Namely, you're looking at 50,000 doctors, and they're the 50,000 most profitable doctors from 2016. According to the amount of money, most profitable according to the amount of money they received in Medicare reimbursements from the United States government. So those are the vertices that you see here on the diagram. The edges, or the links, or the relationships that we have drawn on this graph visualization between all of our doctors are the patients that these doctors shared in common. Now, for HIPAA regulations, every edge represents 7 patients or more so that you can't reverse identify any patient. But those are the first 2 fundamental topics and ideas that you're going to run into when you're working with graph databases and graph tech. The next thing that you're going to find quickly is that when you're working with graph data, your mind is likely going to want to visualize the clusters that exist amongst all of this new data. And so here is another representation of healthcare data, but we're looking at the clusters within the different doctors. Clustering is the exact same that you would think of when you're working in other areas of data science. It's just ways to group the data into some type of logical component. We're going to talk about a few different algorithms or metrics on how you would group your data into clusters in the analysis section. Right now, we're just kind of talking about visualization. When you find clusters, this is where graph tech can start to be kind of fun. You start to introduce a few new terms that come from the graph theory community that make a lot of sense in how we navigate our world. And the first one to consider is a bridge. So a bridge out in the real world connects 2 land masses together, right? And if you remove that bridge, you can't walk from one land mass to another. In a graph, that's the same thing of what an edge would be. An edge is going to connect 2 vertices or maybe 2 clusters together such that it's the only edge that helps you get from one cluster to another, or even all the way down to one vertex or another. So I'm kind of pointing to a set of edges here in this image that represent a group of edges that bridge you from our outlier cluster on the right to the main central cluster there on the left. What's most fascinating about graph data, and you can go down the rabbit hole on all of these really cool layouts, is that when you're working with graph data, there are so many different configurations on how you look at it that they already begin to tell different stories depending on the layout that you're observing. The 2 pictures you see here use the same data, but they're plotted differently. So we're looking at the top 50,000 most profitable doctors from the year 2016. The image on the left, we created a force-directed layout just so that we can lay out the graph as far out as possible and see how it's organized. The layout on the right takes all of the doctors and it plots them according to the lat long of their primary practice location. Now, each of these is already visually telling you a different story. On the left, we can talk about similar doctors because they're clustered together and maybe we have similar patient groups. Whereas on the right, now we're starting to tell a story about how the healthcare industry in the United States functions, because we can see that all of these doctors are coming from different geospatial regions in the United States. Fun fact, this image on the right helped unveil a fraudulent use of the Medicare system through billing for blood samplings or pathology results in Miami, Florida. So that's the doctor in the lower right-hand corner, that really large vertex. That doctor is now in jail for illegally using the Medicare system in the United States for over $20 million of Medicare fraud. Each of these images is very valuable for understanding the data and tell you two completely different stories for the business. If you're very interested in data visualization, one of the fascinating areas I already mentioned to talk about is layouts, when you can take the same data and create completely different dimensions of understanding, like you see here. Here's 5 examples of the same data, just not the healthcare example, just a generic example, of all isomorphic graphs or graphs that are identical. And you get different information from each of them. Some of them are not helpful, like the first one in the upper left, it's a random visualization. But the one right below it is a planar visualization, where you attempt to draw out the entire graph without any of the edges crossing. That's what planar means. So it's very fascinating to see how all these layouts can generate different results in your mind. And a shout out to some fantastic blog posts that are written on this on Medium. I have a source there in the lower left-hand side if you want to kind of go find her posts. It's going to be a theme throughout the next 3 sections, because I believe that Elise's material on Medium is excellent in laying out the space. So I see some questions and I'm going to answer them before we move into graph analysis. So thank you guys so much for asking questions. So over here, the next question is, how do you see the adoption rate towards this technology? And is the industry investing to make it better, reliable, and tools to make it easy? The adoption rate of graph databases is on the upward trend. I personally witnessed in database technology, not just graph database technology. I personally correlate and witness the adoption of a technology with about a 10-year lag. Relational database technology was originally introduced 1970 with the COD paper, but not really until 1980 did we have the technology up to date and available to use widespread, to where relational databases really started to take off. We saw that same 10-year lag again in the NoSQL wave that started in about the early 2000s. The event to point to there is the introduction of the internet and the web and applications that are being built on the web, where you needed new shapes of data. We were working more with document structured data, other things like other data structures like that. But we didn't really see the full wave of NoSQL technology available to handle web scale and speed until about 2010. We're in that same 10-year lag right now for graph database technology, where Neo4j and Aurelius and some of the early inventions and early work around using graph databases and graph tech came out in about 2009, 2010. So we're at that 10-year point to really see how it takes off. And the analysts that I speak to in different companies really are seeing an upward trend. To make it easy is my ask and my goal for the graph technology industry. I think we need to do a much better job at making a lot of this stuff easier to use. Thanks for the questions, I love them. That's just a quick tour of graph visualization. If you found any of those topics interesting, I recommend going off and doing a self-guided study, finding ways to pick up these tools and start working with it on your own. Personally, the visualizations that you saw on the slides and that you're going to see here in the next set of slides, they're made with a tool called Gephi. Gephi is an open source tool that helps you do graph visualization at scale. It's the main tool that I use just because of the amount and volume of data that it can render. It's not an endorsement, I'm just what I use. Next up, I want to talk about graph analysis. We're going to go through 5 terms in graph analysis. Now, this is a very high level description of these 5 terms. So if you find them interesting or you want to dive in more, I absolutely recommend getting some more resources. My goal here for these 5 is to at least start to help you navigate the difference between them with some high level images and high level descriptions. And so let's go ahead and just dive right into betweenness centrality. You have already seen an example of betweenness centrality, and I like to start with that because when I'm working with new graphs and I'm thinking about how to draw a graph, I like to spread out the data so I can see it as far across, like as far laid out as possible. And that natural process of how I'm thinking about graph data essentially is what betweenness centrality is. So that's one way to begin to think about betweenness centrality. Essentially, this topic is starting to give us a bridge between understanding graph visualization into graph analysis, just through this one image. So graph clustering is trying to group together the nodes so that we have densely connected regions together. And typically, you want to group them together algorithmically with one of 2 options, either local weights that are close to the vertex or the edge, or a global distance or a global property about the graph, as that vertex relates to a global property. Betweenness centrality is the latter. We're taking a global metric, namely the global distance, about an individual vertex, and we're starting to group them together. And naturally, that's what you're thinking as well when you're trying to lay out your data and spread it out as far as possible into natural clusters. So betweenness centrality is essentially clustering by a global distance metric. It's understanding for any individual vertex how many times it's in the shortest path to anything else in the graph. So that's what betweenness centrality is. It calculates how frequently a vertex or an edge occurs on the shortest path between all pairs of vertices in the graph. What you're seeing, by the way, is you're seeing your mind get drawn into separating these two groups of vertices into separate groups. And that's one way to begin to understand the visual implications of betweenness centrality as you're looking at how a single vertex is on that central path to any other vertex. The next kind of clustering or algorithmic metric you're probably going to run into is called community detection or modularity. And this is something I didn't mention when we described this image before. So let's talk about it now. So we talked about the vertices and the edges of this healthcare graph, but we didn't talk about where the colors. So the colors of this image, the oranges, greens, purples, blues, they represent the different communities that these vertices or that the doctors belong to. So these communities were detected through the modularity algorithm that it is in Gephi. And you can essentially start to see that all of the orange vertices grouped together, the green vertices grouped together, the purple ones, and they're essentially communities of physicians that have similar networks of patients. So now there's a very interesting business questions that I can imagine you all are thinking of like, these are very interesting networks that are happening around the United States. And likely, we're looking at, say, I believe in orange, that's going to be the Mayo network that exists around the Southeast and different things. So this is another way to think about graph analysis and how you can understand business questions in a visual implication. The next topic to think about when it comes to centrality and clustering is degree centrality. Degree centrality is essentially stack ranking all of your vertices according to those with the most number of edges. So the degree of a vertex is the number of edges that touch that vertex, either coming into it or out of it. So the most central vertex here, actually one of the vertices with the highest degree or a very high degree, is shown here in the lower right. If you would like a different example, the most central vertex on the Twitter graph is Barack Obama. Barack Obama has the most followers, I think at 122.4 million, if that's up to date. And so you can kind of think of, most highly connected vertex is going to be your top ranked vertex from a degree perspective for degree centrality. When you are looking at the connections that exist in your graph data, so you're thinking about how highly connected one vertex is to another, you're likely going to find a scale-free distribution in that graph. So it's very common to model your data and then want to understand how highly connected some sections are versus others. And if you see scale-free, I just want you to immediately picture this elbow curve, essentially an exponential curve. But the point here is that most natural graphs create a scale-free distribution where the majority of nodes are very, very lowly connected, or most of the vertices in your graph only have a few edges. But you're going to have very few vertices that have extremely high degree. And Twitter's a great example of this. You only have so many vertices that have, 10 to 100 million followers, whereas most of the vertices are actual tweet handles. The handles on Twitter only have a few followers. I want to draw your eye back to this visualization because you're basically looking at what a scale-free graph looks like in a visualization. You are looking at, in the upper right-hand corner, this yellow vertex is the most highly connected vertex, and that's going to be, that's essentially the vertex that represents the most connections in our scale-free graph. This group down here, the technical term of this is the hairball section. This hairball section of the graph is the majority of vertices that only have a few edges to them. And it just so happens that this is the section of the healthcare graph that represents primary care, general physicians, and the more entry level, non-specialized. I'm looking for that word. The non-specialized area of medicine. So we would call this section the hairball. Super technical term if you only can remember one after this. The last thing to draw your eye to for algorithms that are extremely popular are collaborative filtering. I absolutely love all the questions, so I'm going to pop over to them here in a second. For collaborative filtering, that is the way that we do recommendations in graphs. It's one of the most beautiful ways that we do recommendations on the back of Netflix, as an example. To point out to how recommendations with collaborative filtering work in graphs, I want to point you to two vertices. We're going to say that you're the vertex that is yellow and the larger yellow vertex, and using collaborative filtering, we would recommend the other yellow vertex I'm pointing to you. The way you do recommendations in graph data is by walking and counting. So you can imagine all that information you may go out and find about collaborative filtering and how complicated it can be, but this is why I love graphs. When you need to do recommendations in a graph database and you set up your connections, to do a recommendation, you just walk from one entity through a few layers to a set of entities, and then you group count them. And that's basically how collaborative filtering works in a graph database. So what you can imagine, if you look at the yellow vertex I'm pointing to that we say is you, we would say that you went to this set of 3 yellow physicians here that you can see in the center. And all of these also had patients that went to this physician over here. So that's going to be the most highly recommended doctor for you also to see in this healthcare example. So boiling down collaborative filtering to walking and counting absolutely is a win when it comes to using graph technology. If you're curious about the state of graph processing and graph toolkits or libraries, here is likely going to be the slew of vendors that you find out there to do graph processing and different technologies. Again, I think Elisa's does a brilliant job at laying this out for you. I can't highly recommend it enough. So I'm going to leave this slide up and come over here and check out some of the questions. And it says, why are some of the edges light? Are there some type of weights attached to or presenting multiple paths in the previous slide? Yeah, great question. And I think that we have some of the light edges on both versions of this image, both the United States version in addition to the scale-free distribution version. So pardon me while I flip back to that one as well. Some of the edges light, honestly, they're just light because we don't have as many there. We're looking at real data, and we have a few hundreds of thousands of edges on this image. There's over 50,000 vertices, and then probably almost 1 million edges. I haven't counted them in a while. Sorry about that. But it's just a density thing. I drew them as light as possible so that once there were many of them overlapping, you could have a better visualization. So no weight on the edge. It's just a density. And thanks for the questions, love them. One last section to get through here, and I think we have about 10 minutes left in this session. Yeah, no problem. Thanks for asking the question. So in this last section, what we're gonna do is we're gonna switch away from talking about healthcare examples, as I mentioned earlier, and we're gonna give you a tour of what I would say are 8 most common words you're gonna find when you start working with graph databases. Personally, the evolution that I've seen hundreds of technologists go through when they're new to graph technology is that they start with graph visualization. They really dive into understanding their data by using graph analytics or understanding global properties about their data. And then likely if they find something very valuable, like doing collaborative filtering for recommendations, you're going to want to pick up a graph database to do this in production with your application. And that opens up a whole new world of terms and types of graph databases as well. So let's go through those now. One of the longest running types of graph databases are those of semantic graphs and the semantic graph community. The connection between semantic graphs is that you are essentially modeling a corpus of text or documents, and you're extracting triples from across all of that text, and you're modeling them into vertex, edge, vertex triples. It's one way to start to think about an oversimplification, but it's one way to understand the difference between a semantic graph and a property graph. Property graphs are personally the ones that I've been working with the most. The visualizations you've seen thus far have all been property graph visualizations. And if you've got experience working in relational technology, it's going to be the easiest one to step into, because essentially you have the idea of an ERD, which is what you see in the upper left, an entity relationship diagram. It's how you model all of the entities and then the relationships that exist in your, likely your Postgres or your MySQL database, how you would model out all those concepts in a visual diagram, creating your database schema. And what you see on the lower right is a translation of an ERD from a relational mapping into what we are calling a GSL, the graph schema language, in the lower right. So you still have the same entities, a customer and account, but now we're more naturally representing that connection directly from a customer to an account to say that a customer owns a certain bank account. When you get knowledge graphs together with property graphs, you get, or oh Lord, I meant when you take semantic graphs together with property graphs, you get the idea of the knowledge graph. What you're seeing here is just a clip, a screen grab from 2015 when Google open sourced their knowledge, or were releasing their knowledge graphs. And the idea here is that every single domain that we work with has a whole multitude of data sources. You've got text, you have legacy data systems, you've got streams of data coming in. And when you want to represent all of that in one graph system, that's where the knowledge graph community is really starting to come up together. Word to the wise though, I have personally fallen in the trap of being really excited to introduce graph technology into a business to solve a problem. And we essentially went after the knowledge graph mantra to start with. I want to model everything because this all makes sense in this new paradigm and I'm really excited about it. But without specificity, a lot of these projects I've seen get shelved. But I would absolutely love for someone else to prove me wrong. So when I recommend specificity, that's going to be certain ways to use graph databases in production, which I'm about to get to here in a second. When you start to implement graph databases, you're going to find a lot of information out there about ontologies. This just means words. This just is talking about the topics that you're trying to connect in your graph database and how it is useful to the business unit user and creating a specific language that your developers are going to use. So just have those two associations together. When you're using graph databases, what you're going to traversals. So instead of doing select from where and looking at a table, you're now thinking about walking through your data. And that's what a traversal is in the graph world. It's starting somewhere on a vertex or a group of vertices and walking through all of those edges to find something valuable. We're going to talk about the 3 most popular ways that I've seen traversals done in production apps, and then I'm going to take your questions, and that's going to be it. So the most popular way that people are using graph databases, specifically property graphs in production applications, is what we would call a neighborhood. It's typically the idea that you have an existing set of databases about customers and their data is all over the place. You want to create a graph database that centralizes the information about the customer and stores the relationships about that customer to their information in the account database or the information into the phone, into your products, etc. So doing these neighborhood traversals, like start at this customer and tell me everything about them, is the most common place to start. That's also the same use case where a developer had 150 lines of a query in HBase that they translated to 20 lines in a graph database. The second most popular way that people use graph databases in production are to query hierarchies or to query trees. Humans basically organize themselves as hierarchies. That's how we are probably organized at work. And it's really common for companies to want to say, for this top of the hierarchy, name of the CEO, tell me all of the employees. And so you're going to walk down through that tree, through all of the layers and collect all of that information. It's very nested. It's an unbounded amount of nesting. And that's why graph databases are extremely powerful for representing this and making the queries extremely short and tight to get this information back out. The third most common way that you see graph databases used, and this is done all the time, it's with paths. So you probably are on LinkedIn. You could search for me, and you're probably going to see how closely connected we are. So here between myself and Tim O'Reilly, we're a second connection. So in my mind, I see that it's me, some set of people, and Tim O'Reilly. So that's my path between myself and Tim. And down there, LinkedIn even gives you the mutual connections section there, that set of friends in common, so that you're able to start to contextualize how you know somebody on LinkedIn. For graph databases, here is a quick snapshot of all of the different technologies out there. Again, I think Elise does a brilliant job putting this up on Medium. So if you haven't found her posts already, I highly recommend you go that way. And in interest of time and wanting to make sure that we stay on time, I'm going to come over here and ask, go through a few questions and see if there is anything we can close with here. Can you please provide more resources for building knowledge graph for improving search? That's a really fantastic question. And it's a fantastic question because I would personally like to know more. But typically when I have this conversation, people who are thinking about search really are thinking about wanting to typically do character edit distance say in the Google search bar when you are trying to understand and search for a certain topic. And that type of process in a graph database is more like, I need to find the entity where I'm trying to start my graph traversal. And then from there, I want to walk through its connections so that I build up my context about it. So when I'm thinking about the search question, there's a major difference between understanding where to start in your data using using character edit distance for properties about the data versus this is the information I have and I want to understand the context around it. The first of which, common use for that is Elasticsearch, common tool for that. The second of which, building up context. Those are the three patterns that we just walked through. Context is usually built up as understanding neighborhoods, understanding the hierarchies that exist between that entity and recursive relationships underneath it. Or context is built up by shortest path. How closely connected is this one thing to this other thing? So search is a complicated question. Maybe please reach out to me on LinkedIn or Twitter. I'd love to dive in more so that I can provide a good answer. So to kind of wrap it up here, I really appreciate the questions and for you all going with me here on this one. We've been just really talking about these three things: how graphs mirror human thought, how through using the right tool for the shape of data, they're making technology teams more productive. And hopefully you've seen through paths or neighborhoods or hierarchies, new features that you can bring into your pipelines. And remember that all data has a time and a location and a relation. The context about a data that is super vital and important for understanding an event is why you would need to be using graph databases or graph technology. I can't thank you enough for coming to. I'm extremely active on Twitter and LinkedIn. You can find me on both places at Denise K. Gosnell. So send me a question, reach out to me. Would love to chat and hear about what you're building. But thank you so much for coming to this session, and I will see if there's any other questions over here.
Thank you so much for a great talk. We really appreciate it. If people have any more questions, we do have a couple more minutes. And then also after this is our lunch break, where we'd love it if people checked out the networking sessions as well as the expo. And then we also have a community room open as well.
Yeah, and I see a really great question. Thank you so much, Renee. I see a great question here from Leslie. I was wondering if you could expand more on the idea of specificity of use cases with regards to knowledge graphs. Do you have more examples of good and bad use cases specifically? Absolutely, Leslie. That's a fantastic question. In my opinion, the canonical bad use case is that I want to model everything in my domain because it just makes so much more sense to model all of the relationships that exist in your data like a graph. And your team is going to spend a lot of time arguing over what's a vertex, what's an edge, and you're probably going to spend and waste a lot of cycles just trying to shove your data into this thing. And the lack of specificity there is it's very fascinating to go through that exercise. But what are you trying to get out of your graph database that's valuable? What query or what information do you need to design for to make sure that your graph database can answer that question? And so that's the gap. And the 3 good examples, or even 4 good examples I do go through in detail in my book. The 4 common templates that we're starting to see are modeling for neighborhoods, hierarchies, paths, or collaborative filtering for recommendations. Those are 4 very specific ways to model your data, and then 4 very specific ways to query it to get meaningful information back out. Happy to start a conversation with you on Twitter or LinkedIn if you want to dive into that more. But the bad is, let's model everything because this is awesome, because you're probably not going to get anything out of that. The good answer is to think about where one of those 4 templates, neighborhoods, hierarchies, paths, or collaborative filtering, can apply and be used to drive business value from the example you're building. Another great question coming in, can knowledge graphs have multiple node types? For instance, a node might represent a natural language embedding and another node might represent something else. Absolutely. The best part about using graph databases is that it really is in the intersection of art and science. Any edge or any vertex can have properties on it. So those are the 3 fundamental elements, by the way, when you're working with graph data. It's going to be vertex. Is it a vertex? Is it an edge? And then properties on each of those entities. So for your question about having multiple types, a Vertex is going to have one primary type, because on disk in your computer, you're going to have to essentially silo it off in some way. But after that, it's very common if you have customers who need to have multiple types, that you'll have a property, and that property can have like a list type, and you have multiple designations of what that property represents. So I'm thinking, going back to the healthcare example, a Vertex is a doctor. And then when we had a property on that Vertex, we wanted to know, I think there are different forms of not primary care as an example, their specialty, that's the word. They needed to know what their specialty was. So they had a primary specialty, a secondary specialty, and then also related specialties. So we had that as a list property on the Vertex, so that we could look at all physicians who are primary care physicians, or all physicians who are behavioral therapists. And there'd be a different way to sub-select groups of your vertices based on property. Thanks for the patience on the long-winded answer there. It looks like that's it for questions. Didn't mean to go a minute over here, Renee, but
no problem. Thank you so much.
I really, really appreciate the support in this session.
Absolutely. Well, everybody, enjoy having a bit of a break here for lunch. Jump in and check out the other sections, and we'll be back here in not too long.
Awesome. Thank you guys so much. Have a great rest of your day and a fantastic weekend.